Hi, in this video we will discuss about object oriented programming concepts. OOP. OOP stands for object oriented programming. There are two different types of programming. One is procedure oriented, the other one is object oriented. Procedure oriented programming is all about writing procedures and functions that performs operations on the data. C language, basic language, etc. are the examples of procedure oriented languages. Object oriented programming is all about creating objects that contain both data and functions. Java, C++, etc. are the examples of object oriented languages. There are different concepts of object oriented programming concepts. Here we have classes, we have object, abstraction, encapsulation, polymorphism, inheritance. All these things combine to form the object oriented programming concepts. Let us start from object, then we will go to class, we will see about encapsulation and abstraction, then go for inheritance and polymorphism. Okay. So, let us go to the object. As I mentioned, there are four concepts of object oriented programming which are based on object and classes. So, based on this object and class, we have these four concepts of object oriented programming. One is encapsulation, abstraction, inheritance and polymorphism. Let us understand the object and class first, later we shall discuss on the concepts. Object. If you look at the definition of the object, it is instance of a class or occurrence of a class. What is a class? Class is basically a design or a blueprint of a object. So, let us go deep into objects. Object, as discussed in the object oriented programming, it contains data and function. We call this function as methods also. So, as definition says, or as we have discussed in object oriented programming, it contains data and functions. If you look at an object, object will look like this. It may contain data 1 and data 2 and it may contain some methods or functions, or it may have only data or it may have only functions. Okay. So, now let us discuss more on this data 1 and data 2. This data 1 and data 2 which is available in this object are physically available to you, where we can store the values in data 1 variable and data 2 variable. So, basically these two, data 1 and data 2, are variables, and it will also have some methods. Using the object we can call these methods. Okay. Now, let us come to the class. As per the definition of the class, it is design or the blueprint of the object. We define a class based on our requirements. We can have data members based on the requirements. We can have functions or methods based on the requirements. So, based on the requirements only, your data members at the same time function members or a method will be put inside the class. To understand the above concept of the class, let us understand a new term called as primitive data type. What are primitive data types? Primitive data types are the data types that are built in or predefined data types in a computer language. if you look at C language or C++ or Java, any language will have some primitive data types. Examples, in C and C++ you have integer. This integer is a data type which is a primitive data type. It can store integer values. You have float. Float is a data type which is a primitive data type in C or C++. It can store float values. We can use these data types directly to declare the variables of these types. For example, you have integer a. Here a is a variable of type integer. Okay, there are different types of data type. One is primitive data type which is been predefined in a computer language like C or C++. There are some user defined data types also, where user can define the type of the data and he can use that program, you can use it in the program. For example, structure. Structures are the data types which is used to define user defined data types. For example, employee structure. Employee may have number of properties, like for example, his employee code, he may have employee name, employee basic salary. Okay, these three are properties of the employee. Okay, so for storing the employee code you may require integer type, for storing the name you may require string, for storing the basic salary you may require float type because it may have some decimal points. So, but I wanted to define a data type called as employee, which is a combination of employee code, employee name and employee basic. I can use structures. These structures are available in C language, you can use it in C or C++. Similarly, you have something called as unions, you have enumerators, and in C++ we have, or in object oriented programming we have something called as class. So, a class is nothing but it is a user defined data type with data members and methods. In other words, we call it as a design or a blueprint of an object. To understand more, let us take an example in C++. Look at the example below. So, here I have a class. Right now you do not worry about the syntax as what I have written here, just look at the class here. The class name is going to be called as a rectangle, and you have two data members here, one is length and breadth, and you have two functions or methods within this particular class. So, class is combination, this class rectangle is a combination of length and breadth, and set data and display data is nothing but they are the two methods which is available in this rectangle. Okay. So, now rectangle is basically a design. So, what I have done is here is I have designed my rectangle class, okay, which has both length and breadth, okay, and I have defined two different methods called as display data and set data here. Okay, the definition of this particular function set data and display data functions are defined inside this class itself. Okay, so now if you look at the class rectangle, it has data members, at the same time it also has the member functions or methods. Above is an example for the class called as rectangle. This is an example for a class called as rectangle. We have two data members and two methods in the rectangle class. There is only only definition is available here, but there is no physical allocation done for this rectangle class, which means that I have only made the design here, and Physically you will not be in a position to use length or breadth now, because it is only the definition of the rectangle. How to use this class, how to use this particular class here? We have a program, I have written a program here how to use it. We saw a rectangle class which is already existing here, which has length and breadth as a data member, and we have two members, function members, member functions, which is available here in the rectangle class. And you see there are two different keywords here, private and public, which we will be discussing little later in this video. Now let us go to the class now, how to use the class. So what you do is, in the main program I have written a rectangle. Basically it is like declaring a variable of type integer. So here we have declared a variable of integer type, and the variable name is a. So now a is a variable of type integer. Similarly here I have declared a variable r1 and r2. There are two variables which I have declared, r1 and r2, which is of type rectangle. And what is this rectangle? It is nothing but it is a user defined data type defined like this, which has length and breadth. At the same time we have two different functions. So what I am doing here in this case is, I am using r1 to call the set data. So how do I call that one? R1 is basically an object, R2 is also an object here. Both are going to be objects of rectangle type, and rectangle type is having two different functions. I am going to call these two different functions by using the object. So R1 dot set data, which means I am passing this 10 and 20 here, and this 10 and 20 is going to be set in the length and breadth here, which is coming here L and B, and this L is been stored under length and B has been stored under breadth. And similarly I am calling this R2 dot display. R2 dot display is going to do what? It is going to display length is equal to length and breadth is equal to breadth. Okay, so I am using this R1 to call these two data here, to these two functions here. I am setting the data, at the same time I am displaying it here. Similarly, there is another object called as R2. R2 is, I am using this R2 to call this set data and R2 to call the display data here. So here you see here a class has been defined, okay, and I have declared two objects here. Okay, once you say rectangle R1 and R2, only then you have R1. R1 will have length and breadth and R2 will have length and breadth and the two functions. So here rectangle is basically the design of an object, and R1 and R2 are the objects which is the instance of the class. Okay, this rectangle is basically a class, okay, and that particular class instance are R1 and R2. Or in other words, we can also say that they are the occurrences of the rectangle object, a rectangle class. So here objects are instance of the class. Physically R1 and R2 will be two different rectangle which is created. So both R1 and R2 will have data members and member functions or methods. We are using this data and methods in the class. So on running this program we get this following output. So if you run this application, if I run this main program, what is going to happen here? We have already defined rectangle class before this main. So you have defined these two objects and you are setting the value for this one. So first value, which is first rectangle R1, R1 is set for 10 and 20 and R2 is set for 30 and 40. You see this 10 and 20 is for length and breadth, and this length and breadth is going to be 30 and 40 here. Okay. So having understood the class as an object, now let us understand the other concepts. Just before going to the other concepts, what I would like to say is, we will just say the definition of the class and object. A class is nothing but it is design or a blueprint of an object. An object is nothing but it is the occurrence or instance of a class. Okay. So, this is the instance of the class and this is the blueprint, this is the blueprint of the rectangle class, or in other words it is actually a blueprint of the object. Okay. So, now let us go to the other concepts. Encapsulation. So, we have discussed about classes and object. Now, we are going to discuss about encapsulation. Encapsulation is basically a process of grouping data and methods in a single unit, is actually called as a encapsulation. So, here what we call as a single unit is a class. So, that is why the other concepts like encapsulation, abstraction, polymorphism and inheritance all are dependent on these classes and objects only. So, the process of grouping data and method in a single unit is actually called as an encapsulation. Example for this encapsulation, we have already defined a class called as rectangle in the previous examples by defining a class. In the rectangle class, we have declared 2 data members and 2 function members. So, we call this combinedly as a rectangle. So, this is what is the same example which you have taken in the previous topic. So, why do you do this one? It is basically a user defined data type that we already understood in the previous sessions when we are explaining in the about the classes and object. It is based on the requirements. So, length is basic, I mean if you look at the rectangle will have length and breadth. At the same time, I need to put some value for the length and value for the breadth. So, for that I am using this function, and similarly I have display data. This display data is nothing but whatever value which I have put in length and breadth, I am displaying it here. So, I have 2 requirements, one is to set the value and at the same time I wanted to display the value. Okay. So, based on that I have defined the that is my requirement. So, I have defined the user defined data type here and I have used that user defined data type in a main program by creating the instance of the class by just creating 2 rectangles R1 and R2 called of type rectangle type. Okay. Now, what is hiding? How it is done? Okay. So, we will get this answer to the above questions with the concept of abstraction. So, what is abstraction? Before going to the abstraction, let me tell you what is encapsulation. Encapsulation, I said, grouping of data and methods into a single unit. This is the example here. By using a class, we are combining data, at the same time we are combining the methods into a single unit. The single unit is called as a rectangle and we use a class for defining this rectangle class, and we are putting both these data members and the function methods within the single unit. So, that is actually called as encapsulation. Now, abstraction. So, to understand the abstraction, let us take 2 examples. It's let us call it as a real time example. Okay. So, let us take something called as a car, and you must have seen the car here, or you might be owning a car now. Okay. We have accelerator, clutch, brakes, steering wheels, gear lever, on which we are operating on it, so that you can move the car or you can put a brake and stop it, etc. If you are a driver of a car, definitely you will be knowing about accelerator, clutch, brakes, steering wheel. Car does not have only these things in it, but car also has engine, it also has gearbox, it also has battery system for lighting, etc. But these things are hidden from us. So we do not know how they operate also. How does the engine work so that the tire moves or tire rotates? That we do not know. We know only about accelerator, clutch, brake, steering wheel and gear lever. So this is one thing. If you buy a car, you have an access only to these four things, okay, and you don't have access to do these things. Actually, you may open and see the engine, but do you know how does the engine is going to work, or you do not know how the gearbox is going to put the first gear, second gear, etc. These details are hidden from us. Okay. Similarly, okay, before going to the next example, in a car, whatever is required to be known to us, that is shown to us. Others are hidden from us. Basically, whatever is the interface for operating the car, only that one is shown to us. The remaining things, whatever is there within the car, is not shown, but in other words, we can say that it is hidden. We do not have to bother about that particular hidden things. Similarly, you have a desktop computers. If you have a desktop computer, we have the following things on that. You have keyboard, mouse and monitor. Okay, but you also have random access memory, central processing unit within the either laptop or in the desktop computer. But on a day-to-day basis, if you are working on a desktop computer or a laptop, we are interacting with the keyboard, mouse, and you are seeing the results only on the monitor. These are all the interfaces to us. But internally, RAM is also used, CPU is also used, but we are not seeing them. We do not know how it works also, but it works for us. So in a computer system, that is a desktop computer, whatever is required for us, it is shown to us, and others are hidden from us. Similarly, in a class, if you are designing a class, whatever is required for the users to use, only that one we have to show it to the user. The remaining things you can hide it. How it is hidden from us? How the class is being designed in such a way that it is hiding something from the real time world, or how it is hiding certain things from us. In a rectangle class, what we have designed previously, we have two different keywords called as which is highlighted in yellow. You can see that private is highlighted and protected is, public is also highlighted here. So we have private and protected. In this example we have private and public. So here we have public and private. Okay, these are the keywords which is given to us to hide or show certain properties or members of the class. Okay, if you define private, all the members which is below this private, so if you look at this private keyword here, below this private keyword you have integer length and integer breadth. So these two are accessible only within the class. If you have this set data is within the class. So length and breadth, which is private member, is accessible here. Okay, so all the members, if it is declared as a private member, all the members are which is under the private keyword will be accessible only within the class, and it is hidden outside the class. So whatever is outside the class, if you have a function outside this particular class, and that particular function cannot access the length and breadth. If you go to public, there is a public keyword. See, whatever you defined after this public keyword, see, this is the syntax which I am using it in C++. Okay, the syntax varies from C++ and Java. Okay. So, in C++ whatever you declare under this public keyword, they are the public members. So, all the members below the public keyword, they are accessible even outside the class also. It is accessible inside the class also, at the same time outside the class also, which means that if I have a method outside the class, that method can call set data and display data. Okay. So, if I say private, all the members which are declared as private is accessible only within the class and it is hidden from outside the class. Public, all the members which is publicly defined, then it is accessible outside the class also. Now, if you take the example of the same rectangle R1 and R2, okay, now I am using this object R1 to access the length and breadth. So, I am trying to put 30 for length and 40 for the breadth. So, I am trying to access the private member here, and using this R1 and R2 I am calling this set data, display data here. So, these things are not having any issues in the previous example itself. We saw the example of calling the set data and display data here. There is no problem in accessing this, but length and breadth are declared as private here, and if you try to access the length and breadth inside this main program, then what is going to happen is it is going to give an error here. So, it says that length is declared as private and breadth is declared as private here. So, this is the error which you get it when you try to access the length and breadth outside the class. Okay. So, by using public, we are exposing the methods to get the access outside the class. By using private, we are hiding the data. So, the user need not know how the data is stored, but it provides access to the data using the public methods. See, look at this one. I am able to access this length and breadth by using set data function, and I am able to display the value of length and breadth by using the display data function. So, here you see that I'm sorry, I am calling this set data, display data by using R1 and R2, and I am able to set the values for R1, set the value for R2, and I am going to show the display output also. Okay. So, this is what is the process of hiding certain properties from the class to the outside world is basically called as an abstraction. Okay. Till now we have seen about classes, we have seen about object, we have seen about encapsulation, and we also saw about abstraction. So, what is a class? Class is basically a blueprint or the design of an object. What is an object? Object is basically an occurrence of the class. Okay. Physically it will be available when you declare an object. We saw an example of rectangle. When I say rectangle R1 and R2, R1 and R2 are two different objects. We saw about encapsulation. What is encapsulation? The concept of encapsulation. Encapsulation is basically combining data and functions within one unit, and that unit is actually called as a class. So, the process of combining data and function is actually called as encapsulation. And abstraction is basically we are hiding certain data which is from the public, so that you give access to the hidden data through public data members. Okay, that is actually called as abstraction. So, abstraction is nothing but hiding certain properties from the outside world. If you think that we have done lot of things here just to understand classes, object, encapsulation and abstraction, Now pause the video for some time. Now relax. Go out and see the objects. So here whatever objects which I am going to say is car. Car is an object. Oven. If you have microwave oven, it is an object. If you have a bike, it's an object. You have a refrigerator, it's an object. Mobile is an object. Okay. Understand what is hidden and what is shown outside, shown to the outside world, and link it with encapsulation and abstraction and understand more. Car example we have already seen. Only accelerator, brakes, gear levers are shown to us. The remaining things like engine, how does it work, and you have gearbox which is not shown to us. Okay, how does it work, we do not know, but by using this four things, accelerator, brakes and clutch, we are able to move the car, we are able to operate the engine, we are able to put the gear, etc. Okay, so car is one object. Okay, and oven, microwave oven is there, bike is also there. If you own a bike, you know you have there also you have a clutch, you have accelerator there, and you have brake and you have gear lever. Okay, so what is hidden there? The motor, how does it work, how does the engine work. And you take an example of mobile. Mobile is also one example of object. Okay, what is the interface given to us? A screen, and you have different apps in that. Okay, so you are just working on it. How does it work internally? We do not know that one, but only the interface we are using to do that. Okay, so relax now, go out, pause the video, go out and see different objects relate to the class object encapsulation and abstraction. If you have done this, if you have already gone out and seen the car, oven, bike and refrigerator, etc., welcome back. We will start with inheritance. This property allows, the inheritance is basically a property that allows a class to use the data and method from another class. So inheritance allows us to reuse the code. In case if you are writing a code, a class rectangle, you are using it, and inheritance will allow you to reuse that rectangle class. Okay, look at this one. You have a class 1, generally you have a class 1, you have property 1, property 2, property 3, property 4. All these 4 properties can be either data member or it can be function member. Okay, if you are inheriting a class, that means you are creating a new class here based on this particular class 1. So what will happen here? Either property 1, property 2, property 3, property 4, all the properties are inherited to class 2, or in other words, few properties are inherited here, like property 1 and property 4 alone will be inherited here, and property 3 and property 2 will not be accessible to the class 2. So the inheritance is basically is nothing but few or more properties or few or all properties of class 1 is acquired by class 2. Okay. So in this class 1 we have methods. Without writing the method in the new class, that is class 2, if we acquire this method in class 2, we can access it. Like for example, let us take an example of class rectangle. Again I am using the same thing because just to understand the concept I am using the same rectangle class here. And you have private integer length and breadth. What is a private member? Private member is nothing but it can be accessible within the class only. And you have public 2 methods. We have seen these 2 methods, set data and display data, in the previous example. now I have added get length and get breadth. Okay. So, this is to get the length of this rectangle and this is to get the breadth of the rectangle. Okay. So, I will get it in the main program other functions. Okay. So, you have public. So, since this all these 4 methods are coming under public, so what is going to happen here? Get length, get breadth, display data, set data, all are accessible outside the class also, but length and breadth are not accessible outside the class because they are private here. So, I have added these 2 functions in the rectangle class, and previously we had these 2 methods or these 2 functions. Now, what I am doing is I am going to inherit or I am going to acquire the properties of this rectangle within this rectangle 1 or RECT1. So, what I am doing is class rect1 colon public rectangle. So, you do not worry about this concept here, just for an example I am taking here. Rectangle 1 is acquiring the properties of rectangle. So, rectangle has some properties length and breadth, and we have 4 methods available here. So, I have a public method within this rect1, and this is going to use this particular this method display area is calling get length and get breadth. Okay. Get length is a function which is available in this rectangle class, and get breadth is available under the rectangle class. So, both the functions are called within this rect class. Okay. Since it is acquiring the properties of this rectangle class, this get breadth and get length is available within the rectangle. Okay. There are certain things we should know about this public derived, public here, and you have public here and private. What is going to happen here when I say private? What will happen if it is going to be public? All these things we will not worry about this right now. When we go to the actual syntax, we will know more about that one, but we are not going to cover this one in this particular video because it is only the concept. But as of now, rect1 is a new class which has acquired the properties of rectangle. Okay. And I am using this methods, I am calling these methods inside this rect1. So, in this above example, I have just added 2 methods to the rectangle class to get the values of length and breadth that we have seen here, and using these methods, the existing methods, using these methods and the existing method in the rectangle class, I have created a new class called as rectangle, rect1. I have inherited the properties of class rectangle in rect1. So, here rectangle class is actually called as a base class, and rect1 is a class which is called as a derived class. So, this is actually a parent class we can say, or it is we can call it as a base class, and this is actually called as a derived class, or in other words we can say it is a child class. So, rect1 is a child of rectangle. Okay. So, but the child rect1 has acquired some properties. So, now you can access this by using the object of rect1 itself. Now, look at this one. I have written a main program rect1 R1 and R2. R1 and R2 are 2 objects which is created, but it is of type rect1. Okay. By using this R1, I am calling set data 10 and 20, and I am also using the method called as, I am also calling the method called as display data. Look at the class definition. You have set data and display data which is available in rectangle class, but since I have acquired the properties of rectangle into this rectangle 1, using the object of rectangle 1, I am able to call this one. So, these are all the inherited methods in the from the rectangle class. R2 is nothing, R1 dot display area. R1 dot display area is nothing but it is a data member available under this rectangle class itself. So this is the member which I am calling in the rect class itself. So I am using the object of rectangle 1, rect1, R1 and R2. This R1 is calling the new method in the rect1, and I have two derived methods here. So similarly, R2 is also calling the derived methods or the inherited methods from rectangle, and R2 is R2 is also calling the new method of display area. If you run the program, you can see that one. Length and breadth is displayed, and area is also displayed here. That is what is declared here in the display area. We are displaying the area here by calling this 2. Okay, so area is also displayed here in this one. This explains you the inheritance concept of OOP. Okay, so before going to the next concept, if you see a code, you have seen the new keywords called as public and private in the code. They are actually called as access specifiers. We have seen about public and private in the previous example itself, private and public, and we have seen private members will not be accessible outside the class. It is accessible only within the class only, and public methods are accessible outside the class. So private and public are basically called as they are actually called as the access specifiers. So there is one more access specifier called as protected, okay, which is not used in the example which I have shown in the above example. So how these access specifiers are used? Private, accessible within the class; public, accessible within the class at the same time outside the class. So what is protected? It is accessible within the class and its child only. So when you are using this protected, use this protected when you are having a derived class. That is, when you are having two classes, one class is getting derived from other class, or one class is inheriting the properties of other class, then you will be using the protected. So only then this protected will be used. So public and private are the basic access specifiers which is used in the class here. So we don't have to bother about how to use the protected, because we are not learning about the syntaxes and all these things. So with this we understand what is inheritance. So what is inheritance here? Basically it is a property of a class. Basically the property is been properties of one particular class is been acquired by another class. Okay, that is actually called as inheritance. So inheritance, in other words, we can say inheritance allows you to reuse the code, or it is used to acquire the property of data and methods from another class. Okay, so now till now we have seen about what is a class, what is an object, what is encapsulation, what is abstraction. Then we finally saw this one, inheritance. Next concept is polymorphism. So as the name indicates, poly means many, morphism means shapes. So polymorphism combined together, it says that many shapes. Okay, generally in a procedure oriented programming languages, any method or a function name should be unique. Okay, which means that same name cannot be given for two methods, two or more methods. Okay, but in our object oriented programming, we have a concept of polymorphism where we can use the same name to more than one methods by just changing the parameters. Okay, that means like I can have two functions and these two functions will have the same name. How do you differentiate this function and this other function which is having the same name? by changing the number of parameters, etc. Okay, it depends, basically based on the language, it depends how to use this parameters. For now we will just say one parameter, no parameter, more than one parameter. Okay, so all these things will differentiate. Even though you are having the same name, you can differentiate these functions by using the parameters. So this concept is actually called as a polymorphism. Polymorphism means basically one method, more than one method having the same name, and you can achieve this by using by changing the parameters actually. So let us take the same example what is there in the what we have seen in the rectangle, but now I am not going to have any data members. Just to explain the polymorphism, I am going to have two functions inside this rectangle class. Now you see there is a private member integer length and breadth. However, I am not using this length and breadth in my program now. Okay, there are two functions available here. Both the function name is going to be poly, but how it is different, how this poly is different from this poly here. This poly is a function which doesn't accept any value. Void means it doesn't accept any value here, but this particular function is accepting one integer. So the method with the same name is these two functions. Okay, here we don't have any parameters. Here we have one parameter which is passed to this function called as integer. Okay, but I am having two different display statement. In this poly, I am inside this poly void function, and in this poly function which accepts integer x, I am in the poly integer x function. So now you look at this one. How do you call this function and this function in the main program? You declare an object of rectangle type. Okay, this rectangle is having two functions with the same name. Okay, and I am declaring an object called as poly. If I say r1.poly without giving any parameters, it is called with no parameter. Now here you see r1.poly with integer value is passed to that. Okay, so there are two different ways in which you are calling this poly function. Okay, now if I call this with no parameter, first it will look for the corresponding type. If you look at this one, poly with no parameter is this function. So it is going to execute this, it is going to display this particular cout statement. And similarly you have poly 10. So here 10 is passed. Here it doesn't have any value to be accepted, but here you have something to accept here, that is integer value is passed to this one. So this is going to be executed, that is it is going to display I am in poly integer x function here. Okay, so you can see the output here. When I am calling this poly function, this particular output is coming here, that is I am in poly void function, that is going to be this method is executed, and when I say poly 10, this function is executed. So that is why it is saying that poly integer x function. So here there are two functions with the same name but two different parameters. So this concept is actually called as polymorphism. That means here how does it polymorphism comes into picture? What is the definition of polymorphism? Poly means what? It is a morphism means basically shape, poly means many. Okay, so this function takes different shapes here. Okay, poly void is one shape and poly integer x is one shape. So this is the example for polymorphism concept. Okay, so now let us with this one, all the concepts are over. Let us go to the concept and just define all these things. So what is a class? Class is basically a design of an object or blueprint of an object. Object is what? It is the occurrence of the class, or it is going to be instance of the class. What is encapsulation? The process of encapsulating, process of combining data and function in a single unit is actually called as a encapsulation. What is abstraction? Abstraction is what is required for the user that is shown or it is exposed, other things are hidden. So the process of hiding certain properties in a class is actually called as abstraction. Inheritance is nothing but it is acquiring the properties of one class in the other class, and polymorphism is another concept. Poly means many and morphism means shapes. So any one method taking more than one shape. So we have seen examples in all these concepts. Okay. If you wanted to execute these examples, we need to understand the syntaxes for any of the languages. Either you can use C++ or you can use Java to understand all these concepts. We can once you learn that languages, you can implement all these things and you can see that one. So basically this video ends here, and with the end of this video we understand the concept of object oriented programming and all these things with an example, and the examples I have taken it from C++ syntax. Okay.